Okay, number 5 says 3 identical pictures are shown below. Also depicted are the wires holding up the pictures at various angles. Use trig to determine the tension in each wire. A diagram for each situation is shown. Okay, so here's what I'm going to do, you guys. I'm gonna do this first one for you guys, where I'm gonna solve for the tension here, this wire acting on this picture frame, and I want you guys to do this one and this one on your own, using the example from the first one. Okay, so notice what's happening here. So I have a picture frame, and it's hanging from 2 wires. So there's one wire that's pulling up on the picture frame like this. Okay. So it's pulling up and to the left. And then there's another wire that's pulling up and to the right. Okay. What I want to focus on here, I want to focus on this wire right here to the left. And by the way, they're both pulling at 15 degrees above this horizontal. So if I find the tension in this wire, then I also know the tension in this wire because of symmetry. So let's look at this. Let's look at this wire right here on the left, this force vector on the left. So if you notice, this force vector is acting at an angle, so I can split this angle up into its x and y components. So okay, if you see here, okay, this vector here is acting in the x direction, okay, at the exact same time that it's acting in the y direction, like this. Okay, so I'm gonna take this and I'm gonna underline that so you guys can see that. So I'm just gonna highlight this left wire here, and notice I split this up into its x and y components so that it looks something like this. Let me make this bigger here. So remember, this wire is pulling up and to the left. It's pulling in the x direction at the exact same time that it's pulling up in the y direction. And if you notice here, they have this label here with this force here right here is 5 newtons acting upward right here. So that's why this force right here is 5 newtons. So the goal is to solve for the tension of this wire. In other words, we're solving for the value of this force along this hypotenuse of this right triangle. Okay, we're solving for, again, just the tension in this wire here. So how do we do that? Well, that's easy, because if we know this angle here is 15 degrees, and we know that this side right here is opposite our angle, we can easily solve for this hypotenuse by using the sine function. Because if you guys remember, sine of some angle theta is equal to opposite over hypotenuse. Okay, so here this is sine of 15 degrees is equal to our opposite side. Again, where our opposite side here is 5 newtons. That's the side opposite our angle. So 5 newtons divided by our hypotenuse, which is what we're trying to find. We're trying to find tension. We're trying to find the tension of the wire. So I'm just going to put a T there for tension, okay, because that's what we're trying to find. So how do I solve for T? In other words, how do I get T by itself? Well, first thing I need to do, I need to multiply both sides of the equal sign by T. So if I multiply this side by T, so put T in parentheses, multiply by T, that goes away. Whatever I do to one side, I have to do to the other. So T is equal to sine 15 degrees is equal to 5. Okay. Now, one more step, I want to get T by itself, because that's ultimately what I'm trying to find. In order to get T by itself, that's T times sine of 15 degrees. So I need to do the opposite of multiplication. That's division. So divide by sine of 15 degrees. That goes away. Whatever I do to one side, I have to do to the other. Okay. So ultimately, I'm left with this. So the tension of the wire is equal to 5 divided by sine of 15 degrees. Okay. So that's ultimately how you find T. It turns out if you put in your calculator, if you do 5 divided by sine of 15 degrees, you should get a force of tension here, this tension force here, you should get the value for this tension force to be equal to 19.3 newtons if you put that in your calculator. So this right here is going to be equal to 19.3 newtons. Okay, so that's the value of tension in that wire. Okay. So if I come over here, okay, that means I can label this force right here. Okay. I can label this force right here 19.3 newtons. Okay. So 19.3 newtons. Okay. So 19.3 newtons represents the tension in this wire and also this wire. Because of symmetry, I know that those tension forces have to be the same. And again, we just use our sine function in order to solve for that hypotenuse there. Okay, so here's what you guys do. Using this exact same procedure, go ahead and find the tension in this wire here, and then find the tension in this wire here. Okay, and then compare those tension values, because when you compare the tension value here, here, and here, the last question asks if hanging the above pictures with a particular wire, which one of the above angles provide the best arrangement? In other words, the most secure. So basically, guys, think about this logically here. If you're hanging two pictures, basically you want to hang your pictures in such a way that you want to produce the smallest amount of tension possible on these wires, right? Because the less tension is acting on the wires, the less likely the wires are to break. And so if the wires don't break, then that means the pictures won't fall. Okay, so that's when the wires are the most secure. That's when the picture's the most secure, whenever it won't fall. So go ahead and find the tension here and here and figure out which one has the least tension, and that's going to give you your safest arrangement, because again, the less tension that is acting on your wires, the less likely the picture is to fall. So there you go.